In this video, I'm going to talk about variance. I'm going to introduce it, and I'm also going to show you how to do the calculations. This video, however, assumes that you already have covered the standard deviation. It builds upon that. I'm not going to start from scratch and calculate the variance. I'm going to assume that you already know how to calculate the standard deviation. So the variance, once you understand the standard deviation, is simply the unstandardized representation of the standard deviation. That's how close it is. So the standard deviation is kind of like an average deviation from the mean in terms of the values in the data file. Well, the variance is the unstandardized representation of the variability. Variance is represented by the letter S. This is how we typically represent the variance in shorthand. And this is the formula that you can use to represent the variance. It's exactly the same as standard deviation, with the one exception that there's no square root. In the standard deviation formula, there's a square root term associated with it, whereas with variance there is not. So you could do all these calculations, which you actually have to do for the standard deviation. You just don't execute the last step in the standard deviation process, which is the square root process. So as a consequence, the variance can be estimated by squaring the standard deviation. That's how simple you can get an estimate of variance, is by squaring the standard deviation if you've done all that work. So in the case of the sleep data, where we estimated a standard deviation of 1.21, that's a standardized representation of how much variability there is in the data, the variance would correspond to 1.46. And you can calculate that very quickly in a calculator like this. 1.21 is the standard deviation, so you can square it and you get 1.46, which is the variance. Now, I mentioned that the standard deviation is the most commonly used measure to represent variability. The variance is somewhat commonly used, but its importance is observed in its greatest way in the calculation of more complicated statistics. And a good example of that is the analysis of variance, which I cover in future chapters. So understanding variance is important, even though it's not commonly reported specifically, because it actually forms the foundation of a number of other statistical analyses. So let's show you very quickly how to calculate variance in Excel. And I'm also going to show you how to do it in SPSS just to give us a flavor for that. But in Excel, we have the sleep data here with 11 cases. And to get the variance, you type in equal, which is a function in Excel, and you write the letters VAR, and you'll see a .P and a .S. And for a variance estimate as derived from a sample to be used as an estimate of a parameter, you have to type in S, var S, estimates variance based on a sample, which is what this is. And then we can write B2 and B12 to capture all 11 data points, close the parentheses, and bam, you get 1.45, which is within rounding the same value obtained with this square rooting of the standard deviation, 1.46. Same estimate. Now we can do it in SPSS as well. Analyze descriptive frequencies, put sleep into the variables box, click statistics, and you can get variance right here. Click continue, deselect frequency tables, and bam, we get 4.55. So all these estimates are surrounding the same value within decimal places, which is 1.46 or 1.45, depending on how you want to go about rounding. So that's the variance, and that's how you can calculate it.